Greetings everyone, Ali here with dedicated video on HTML images and introduction to web page rendering. There's also going to be live coding in this video, but the title was already so long, so I skipped that. So as previously, we would be learning via live coding. I would definitely encourage you to follow along as just watching a video seldom helps. HTML and programming is something you learn by doing and developing muscle memory. So let's begin. I would first write a basic HTML document with image tags. I have two images, one big one and one small, already placed alongside HTML, and you can create a copy to follow along. So for this video, I'm going to create a new page. Type HTML body. We just going to have a body. All right. So let me first create an image tag and let's see what it's about. Image source equal to dot slash page.png and alt equal to smiley. Here we go. So as you might have guessed already, embedded images are different from background images as they are inserted not by styles but a proper HTML element called image element. The anatomy is less than sign image is the starting tag. The most important source attribute where you specify relative or absolute URL of the image file. And HTML is very forgiving about the file type. So you have a full variety of supported types like PNG, JPG, ICO, GIF, APNG, and rapidly gaining in popularity SVG or scalable vector graphics since you don't have to care about resizing those unlike the others, where you do. Since I already mentioned, I should warn you, size of image is a big deal in HTML or front-end world. A website is to be viewed in an absolute ton of varying screen sizes, resolutions, and devices. Your website can be viewed on TV, laptop, external monitor, tablet, phone, among others. It might be open in horizontal or portrait orientation. Then in these devices and mode, someone might be viewing with browser occupying full screen or resized to a corner. And lastly, the screen might be supporting a 320 resolution all the way up to 1080p or beyond, as UHD TVs are now going beyond 2160, and viewership on TV is rapidly rising. Ensuring your website looks good in all those combinations is a dizzying challenge, and images are at the heart of the problem. An image of small resolution might pixelate on a high resolution or big screen and give a terrible result. There are a lot of ways invented to mitigate this, and you should get used to hearing the last few sentences dozens of times on repeat in this series or elsewhere, as this would keep coming up. Don't worry, we shall have dedicated video or videos on responsive design, but since images lie at the core of the issue, I did bring up in this video. All right, let's go back to Visual Studio. Here we are. So coming back to images, the next important attribute is the alt tag or alternate tag, and it is required tag by HTML. It is used to provide a textual description of the image to be displayed as replacement in case image is not available to display on the page or not downloaded yet. I will talk about performance aspects related to image later in the video, and we shall discuss alt tag further in context then. For now, let's play with the images a little bit more. The next important attributes of image element are width and height. Let me first type those. Width equal to 300 and height 400 is 200. Yeah. Here you indicate to the browser what the size of image needs to be when displayed in a web page. The browser would scale that image up or down, just like you saw, to show in dimensions you specify. If you specify only one, it would adjust the other accordingly. Like if I can totally skip height, it is adjusted by itself. And similarly, I can give height only and width is adjusted accordingly. Is that it for width and height? Absolutely not. They are critical for another reason, that is reserving the space for the image on the web page before even getting to it. You see, displaying text is easy and browser knows what to do with it and prepare a rendering plan. With images, things are different. Without width and height, you're just telling browsers via HTML that an image of unknown dimension would show up here. I think I must take a break from images and explain two slightly unrelated things here. Unlike Notepad or your command prompt, where next line of text comes neatly in next line and is very predictable, web pages need to be rendered. The browser, for sake of efficiency, starts showing the HTML as it gets it. So your website starts appearing in browser before images are downloaded or even the HTML page is fully downloaded. The closest examples can be that your art teacher starts describing a scene and you start immediately drawing with your pencils and paper. So she describes mountains and a river flowing through them, and you, her over efficient student, is already giving shape to conical mountains and a river and drawing stones in the river to give it extra realistic touch. When she says, and oh yes, the farmer's cow was taking a bath in the river near his house. Dang it, you have already rendered the scenic river with fish and stones and whatnot. That information came too late for you. Now you need to change the perspective where you can fit a farmhouse and a bathing cow in the scene. You probably need to rub off part of your drawing to adjust the newly introduced elements in the scene. Browsers don't work differently at all. As soon as they get the first few lines of your HTML document and some basic information about, like your CSS, they get hard at work planning and rendering the web page. Your first H1 heading would already be there on the screen before browser even knows there is a paragraph tag, packing its bag or traveling the wire, and server is giving a wake-up call to image to get ready to travel. So if a browser is a hotel reserving rooms for travelers as they arrive in a queue from the airport shuttle, the image tag in this example is like an intermittent call that please book a room for me, I am just taking my stuff off the bus. And the reservation desk books a room for the caller and carries on to the next paragraph traveler and the next span element and so on. And then the image traveler and his finally arrive at the desk with 8 kids. What, couldn't you tell upfront you are arriving with 8 kids? I already booked all the family rooms on the floor. Following the angry argument, a call goes out to one or more travelers already unpacking in their rooms that sorry we found out too late that there is a big family in your group. You need to move to another room as the big room is required for the big family. The room occupants are unhappy to move. The hotel management is unhappy to move already adjusted people around to make room for the big fat family, and all that could be avoided if the caller had just added, and by the way, we have 8 kids with us on the call. In case I did a terrible job in conveying the essential idea here, as the browser is showing the HTML on screen and as its elements arrive, when the image tag comes with no width and height, it is simply queued for download and browser moves on to the next element, which can be, say, a paragraph element. The smallest image is usually bigger than the entire HTML, takes time to download, and browser needs to send a separate request to download it. The next element, that is paragraph text, is already there before browser sends request to server for the image. Showing text is easy. The browser, having no idea what the size of image would be, allocates a few pixels, if any at all, for it, and starts rendering the next paragraph on the screen, and the next, and so on. Then comes the interrupt. The image header arrives indicating it is 400 by 500 pixel image. Couldn't you tell it earlier? Shouts the browser. I thought you would be a 1 by 1 pixel. Wait, let me adjust you. Then goes call to paragraph element that sorry you need to move. What do you mean I need to move? The visitor is already reading me. Sorry, but image needs to be here. I'm making it a funny example, but do remember images might not be coming from the same server as the HTML page and coming from another server which might be slow as hell. And this happens all the time that image arrives after you, the visitor, have started reading the next paragraph. which suddenly moves away as an image starts rendering in its place. It is not funny at all. A website that does that repeatedly will not have happy visitors if any visitors left after a while. And all of this could be avoided if you just include width and height upfront. Then the browser would allocate a blank box of these dimensions when it gets the image tag and renders the next paragraph afterwards. When the image downloads, there would be no flickering, no shifts in layout. Visitor would happily read the paragraph without being affected by new content. Enough talking examples. Let's see all of this happening right in front of our eyes with help of technology to slow down time. Let's start by adding two paragraph tags to the HTML document we were creating. So I'm going to add a paragraph tag and another one after the image. And next up, I'm going to bring in my favorite site, lipsum.com. So we need to bloat the website a bit. So I'm gonna take 500 paragraphs worth of text. That's a big one. I think that's enough. Okay, going back and add this to the first paragraph. Left and copy and paste the same thing after the paragraph. Okay, and I'm going to remove the height attribute from the image tag. Right. And I'm going to copy this URL, the 127001 from the preview, http 1270.0.1 3000 images.html. And next, I'm going to show you a really cool feature from Chrome. So right click inspect, and there's a cool new tab which we are going to look into, and that is called network. So click on it. And what it does is when a page loads, it shows you all the network traffic and the communication that is happening between your browser and the web server. Web server being this 127.0.01 in this case. And it also allows us to replicate the network conditions. So there is drop down here that lets you simulate what kind of network conditions there are. So no throttling is the default, which basically takes full advantage of your current internet connection. But since we are trying to simulate a slow network, we are going to go to custom and add a custom profile. I'm going to rename it slow to crawl and going to give it a Stone Age download speed. Um, let's keep the uploads okay, same here, and I'm going to add 300 millisecond of latency here. Right, so this is going to induce a lot of lag in downloading the web page. So next up, this disable cache needs to be selected because otherwise system is going to try and reuse already downloaded content, so it won't work as expected. So this needs to be checked. Another thing, you cannot use a file URL here, otherwise this slow network traffic simulation won't work. You need a proper HTTP URL to get it working. If you use a file URL from the disk, it would be as fast as it is without any simulation. So I have experienced a bunch of times that this doesn't work upfront. So what you need to do is select offline first, press the refresh button, which is going to show you no internet, and then go back and select your slow to crawl configuration, and keep an eye on the viewport now and see what happens. So in the network tab, the images.html is happening. And did you notice there was a small gap between these paragraphs and then this image started downloading? All right, let me show you again. Nothing happening so far, going as far. See this little gap, and then the image suddenly appears, and the small gap expands into this very large gap. I'm going to show you post editing what happens when the image data was not present with the browser and what happens afterwards. So just one more time, I'm going to refresh. Just have one more time. Look. So see, small gap, and then it expands and pushes the entire next paragraph forward. All right, while we are at it, let me show you another cool features of this network tab. So it shows you all the communication that takes place between the browser and the server. So you see images.html is requested first by the browser, right? And you can see all the request headers that goes in. The request goes to this URL. Request method is get, and there's a whole bunch of other terminology that you don't need to concern yourself with, except the content type, which is text HTML, since we are downloading a HTML file. The browser starts to download the HTML file, right? And when it gets to the point where it reaches the image tag, it just reserves a very little space, like probably 10 or 15 pixels gap, and then renders the next paragraph, right? As it is receiving the image.html. And then at the same time, as soon as it reaches the image tag, it sends another request to the server to fetch the image. And the request URL is 127.0.0.1.300 face.png. It's a specific URL where for your image, right? And the content type is image or PNG file. And you can see the preview for this response. Also note that on this timeline, you can see how much each file took to download. So the images.html, if we close this, we can see it took around 12 seconds. So from here to here, it's the HTML file which took time to download. And if I select face.png, you can see that it started somewhere around the 5 to 6 milliseconds part, where somewhere in the middle, since our first and last paragraph are roughly the same size, somewhere in the middle, the browser encountered that there is an image tag with a file name that needs to be downloaded and queued the download. So this is what the timeline is representing. There are useful techniques for debugging your websites later on. I would also highlight that if you press Shift key and hover over any file, you see all the dependencies being showing in red. And if you select a file with the Shift key, the green indicates the files that requested them or what they are dependent of. Right, so a couple of more things about this. So this portion also shows you in the network tab what is the size of each content that is being downloaded. So since we bloated the image.html a lot with 500 paragraphs of text, it is in fact larger than the image itself, but usually that's not the case. The HTML files are usually much smaller than images, and there can be a lot of images. And this also shows you the time it took to download the file. And there's a waterfall thing, which is going to be too much to explain for this video, but it shows you how much time it took for the request to get to the server, how much time it took the server to respond, and then what time it took to download the content itself. So you can investigate any problems with your web page in detail using these tools. Now that we have seen what happened in this pass, let's go back to Visual Studio and have a look at what happens if we introduce width and height. First, I'm going to show you what happens if we just add width. So let's add width and not the height and go back, reload the page to see what happens. Keep your eyes peeled. Scroll, scroll, scroll. See, little gap, which expanded again, right? So only introducing width did not help at all, right? The browser still had to shift the content. Now let's see what happens if we introduce height as well. So I'm going to introduce height equal to, it's gonna look bad, but I'm going to introduce a longer height to just make a point, 400 pixels. All right, go back, close it, scroll, 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 and see the big gap was already there. Not because I scrolled slowly. Uh, let's see that again. See, scroll, scroll, scroll. See, the height was already there. It was pre-allocated before rendering the um, next paragraph. If you're not seeing the same results, you can go to your custom configuration and edit it and make it even more slower than it previously was to get the right experience. So just another word on rendering. Repainting or adjusting the layout is extremely expensive, not just in terms of you know shifting, but also browser resources. Browser has to change its entire rendering plan and whatnot. We're gonna look at website performance in their own dedicated videos as well, but just keep in mind that as a good web developer, your job is to minimize any extra effort on your browser part. Every single micro or millisecond is precious, and you need to save it wherever you can. Right, since the video is more about browser rendering and performance than images, and we'll discuss the other image attributes in the next part because it's quite a lengthy video by now. So I'm just going to quickly show you another thing that affects the browser performance very badly. So in this HTML file, we were not using CSS, but let me see if we can introduce. So for the sake of time, let me just going to go ahead and copy the relevant section from here. Okay, it's gonna introduce a bunch of garbage, so we can have a dedicated CSS images.css and images. Okay, and in this images.css, I'm going to first off image width colon 300 and height colon 400 pixels. Okay, and I can go down and remove height and width from here. Control S, go back. It's already loading because we are using this 127001, which is the live preview. It doesn't happen elsewhere. So everything is cool. All right, now I'm going to show you what another interesting part. So did you know that we can have comments in a CSS file? So by using /static, we can have I am a comment. And you can write any comment describing the styles in the CSS file, and your CSS would work as expected without causing any issues with the browser. The browser is simply going to ignore the comments. We can go and see that it is reloaded and correctly using the styles specified in the CSS. Now, what I'm going to do is I'm going to, and also you can see that the images.css is part of the network traffic that you saw, and it took around 1 second, right? And it is 271 bytes. All right. I'm going to, and it almost took the same time to render. See? All right. So now let me do one malicious thing, which is going back to loremipsum.com and copy the 500 paragraphs worth of text, come back to images.css and paste it, and to make it more obvious, paste it again. All right, the file must be big now. If I go back here and stop the reloading and reload and reload again, what is happening? Where's all the text? All right, let me just to make a point, let me first clear. Um, it's already there by simulating an offline mode and then slow to crawl followed by refresh. Now let's see what happens. The image.html is downloading. Image.css is also downloading. Keep an eye here. Downloading, 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 downloading. Are you tired of listening to downloading? Yes, I am tired of saying downloading. Yes, but see, the the first paragraph or HTML render did not happen until the full CSS file was downloaded. If you don't believe me, look again. Sorry, offline, refresh, slow to crawl, reload. Yeah, keep an eye here. 20 seconds of your life are gonna get wasted, I know, but this is a very important lesson worth wasting 20 seconds for. So, and now around 19, when you see 19, see the page appears. Why? Because HTML needs to know how to render the first element it receives. And if it finds a CSS link present in its header, it knows that its display of the element that it has received might be controlled by the contents of the CSS file. So it's going to delay displaying the CSS until the CSS file is fully available. So, so although the web page, the browser is trying its hard to show the element as soon as it can, it is only going to do so once it has information or required information available about that element. So since it is an unknown area that there is a CSS present, which can potentially have styling about the particular element, the browser is not going to display the first element until it has the full styling information available with it. That is why anything present in the head section or the links present in the head section, whether it is CSS or JavaScript files, they are going to slow the rendering of the website and ruin the user experience. So you need to keep your CSS and JavaScript files really small so that they don't become a blocker. So a very important point to remember is, and I know that is a point to be made in the performance videos, but the website needs to be available for view as soon as possible, really quickly. Note CSS and JavaScript are what is known as render blocking resources. The browser needs to fully download them as they are unknowns, and browser has no idea of what kind of implication they might have on elements it knows about. Your CSS might only contain a style for a link in your footer, but it would block rendering for entire page until it fully arrives. Since CSS can be reused across files for styling and theming, it can get really bloated with styles that do not apply to your home page, but other pages linked from your home page. But your home page, or especially its top part or above the fold part, is your most important resource. Your users get the first impression of website from that, so it should be really performant. For now, just knowing these issues is enough, and we shall cover mitigations in later videos. There are techniques to load a critical CSS for above the fold or first visible portion of web pages as render blocking resource, and defer loading the big fat CSS for later on. My intent here was to introduce you to render blocking resources only and not the solutions. Depending on when you watch this video, the solution video might already be uploaded as part of yet another full stack development course on this channel, or you can subscribe to be notified when it arrives. I would suggest you subscribe anyway, since I intend to keep posting helpful content in the future. And don't be annoyed if I repeat a bunch of stuff there as well, as I definitely would. Alright, this finally brings us to end of the video. Thanks for watching, and please don't forget to like and subscribe if you liked it. Bye.